Just like to step back onto the last information that we saw there. So my wife is not in waste to energy or in waste of any kind. And I was going through some stuff one day and reading and accidentally left out this thing on the PET crusher. She read pet crusher. And she said, "What's that?" And I said, because sometimes I say things I shouldn't, that in the cities, such as Sydney, people live in apartments and they don't have anywhere to put their pet after it's passed away. I am expecting to be let into the house sometime in the next few weeks. So before I start, yes, the introduction did state that I analyzed a lot of waste-to-energy technologies and selected a technology for downer, sort of the go-to thing. But one of the things that we learned was not every technology is applicable for every community, every council, etc. So what we do is we look at the project and recommend or either recommend a technology that is suitable or go with the technology that they're looking at. What my goal is today is to put forward some of the things that people should think about, council should think about when selecting a technology, understanding a number of things within their own domain as opposed to trying to shoehorn a particular technology into the solution. A couple of terms that have been changing over the last little while. We called everything renewable. I mean, we still use the term renewable. I don't want to say we use it loosely, but it's come to represent the organic portion of fuel or feedstock, etc., the green side of things. And we've started ignoring sustainable. And so I wanted to bring that up because, yes, renewable can be your organics, but the waste that we are, if we look at MSW, the waste that we are creating is a percentage organic. Let's say it's 40% or so, depending on the number of bins you've got, of course, in your collection. But there's a lot of things in there that is not organic. But the thing about the sustainable portion of waste is that it just keeps coming. Whether we're in Canada or in Australia, we're really good at generating waste. And I've heard the argument that, oh, well, the non-organic portion can go into landfill and it doesn't hurt anything. But the other way of looking at it is, if you're not diverting it from landfill, you're replacing it with other mining, etc., things that you need. So, in fact, it probably should be looked at, and we have to sort of deviate that renewable versus sustainable and consider it all. So, the trick in looking at to energy solution is to understand how much waste you can commit, because, and that goes back to a number of things. It's not just what my tonnage is in MSW, et cetera, but it's looking at it, and everybody will move forward and say, oh, well, we could handle all the excess tomatoes, I'm sorry, that would be tomatoes here, with this technology. And yes, if you had enough tomatoes, it would work fine. The problem is you need to understand how much waste you have, and if you start divvying up every bit of the waste stream into a particular technology, you end up at a point where you have not enough waste stream to supply any technology. So understand what you can do, how much waste you have, and what your streams are. And that sort of leads into what is the makeup of that waste, understanding the waste, the calorific value, MSW, are you turning it into RDF, are you just supplying MSW, etc., because that will dictate the technologies if we're talking thermal. You also want to understand if you're looking at anaerobic digestion, for instance, or MBTs, et cetera, how clean the waste stream is, because a lot of people are looking at FOGO as another bin, for instance, and you would think naturally that anaerobic digestion is the way to go, but how clean is that stream? Is there contamination? Will the wheels fall off the technology you pick if you decide to go down that path? And I'm not saying that anaerobic digestion isn't a viable path, and it has worked in many communities where they control their waste stream. Typically, it's in the farming side of things where you've got pig manure and things like that, and you know pigs poop manure. You very, very rarely have pigs pooping containers. So it doesn't bugger up the anaerobic digestion system. The other thing is the moisture content, and that leads to understand the calorific value, what you can get out of it, what's your moisture content, and how does that vary through the year. In Canada, for instance, we had you would think, oh, in the wintertime, it's snowing. The moisture rate's probably going to be through the roof. In fact, in the winter, it's really dry, and the moisture rate drops to zero. So that's the front end. The other side of things is, what is your desired offtake? Do you know what you want to do at the end? Australia, from a power point of view, we talk to waste to energy, and energy isn't just electricity. Energy is electricity and transport fuels, ethanols, etc. It's all energy, but what do you want to do? Because that determines what technology that you can use. There are certain things, and if we look at the thermal side, go away from the non-thermal now, you've got incineration, and it creates heat, which can create or run steam turbines, etc. And that's what you can do. Some of the other technologies, whether it's gasification or plasma gasification, etc., create a syngas, and that syngas gives you the ability to do transport fuels. So and there are two things there. There's one, certain areas, such as the ACT, have a renewable program, but they've reached 100%. So if they're looking at a waste-to-energy plant, they're more interested in transport fuels because they can reduce their carbon footprint by taking biodiesel or renewable diesel, whatever the term is, and use that for their fleet. And they bring their carbon footprint down. They don't really need electricity because they've got enough wind and solar, et cetera, that they've reached that maximum amount that they were hoping to reach. And I guess the other thing on there is, how important is diversion from landfill? We talk about the organic side and the carbon footprint, but if you're looking at the non-organics, that's the diversion from landfill. So some of the technologies that create ash, et cetera, there's about 30% ash created from each of the technologies. Some create less. So understand what the diversion goals are. If you're trying to maximize diversion from landfill, one technology is going to give you a better result than another. So I've got a bit ahead of myself. The waste-to-energy technologies are broken into two things, the non-thermal and the thermal. And the non-thermal is mechanical biological treatment and anaerobic digestion. So again, understanding the waste streams allows you to pick which one you want to go with. In thermal, we have incineration, we have pyrolysis, we have gasification, and we have plasma gasification. And not going to get into the debates about who's been here the longest, et cetera, but those are the main players. Anaerobic digestion, as I said, it's great for domestic sewage, organic waste, not great for unsorted MSW. The contamination side of things will stop the system cold. Unless, of course, you spend more money at the front end and make sure that you keep take the contaminated items out, and then what do you do with them? The residue that you get is a stabilized organic matter, can be used for soil amendment, after dewatering, etc. Again, that's understanding what are you trying to achieve at the end of the day. And anaerobic digestion isn't getting rid of waste so much as reducing the quantity is what it's doing at the end of the day. And methane gas is generated and can be used for energy generation, or you can just flare it. When you're looking at the thermal or advanced conversion technology, the definition of the types of technology is really based on the amount of air used in the system. So incineration uses the most air. It's a combustion technology. Gasification falls in the middle when comparing that to pyrolysis, which uses the least. I didn't put plasma gasification on there because it's sort of the operation of that technology allows you to use oxygen or air, depending on how much electricity you're trying to generate, if it's electricity that you're trying to generate. So as I said, incineration, oxygen required to fully oxidize the fuel. It's combustion. I'm talking raw MSW here. I know there's CNI and there's many other types of fuels that you can use, but I had to choose one. So I chose MSW to talk about. The waste is converted to carbon dioxide and water. The temperature range, there are concerns for dioxins and furans. They have ways of controlling that, but it always has been a concern. Again, the bottom ash is about 30% of whatever you start with left is bottom ash. Typically it goes to the tip, unless, of course, the incinerator people will say that there are ways of using that in creating bricks or concrete, et cetera, et cetera. I had one customer and he said, oh, well, I think I'm going to go in that direction. Then he realized he had to start a 24/7 concrete manufacturing system, and he wasn't willing to deviate from his particular line of business to do so. The fly ash from the air pollution controls is an issue, often considered to be contaminated, but you can take care of that as long as you know you have it. And it needs a high calorific waste to keep the combustion process going. So it's the actual waste itself is what's burning, so it's like a wood stove. You've got to keep putting wood in or you lose that combustion. Gasification, it sits between pyrolysis and incineration from an oxygen point of view. It involves partial oxidization. It does require some heat to get things initialized, and then it sustains itself while it's going. The oxygen is added in small amounts for oxidization to occur. It's not full combustion like an incinerator. Temperatures are about 650 degrees Celsius. It does produce a syngas, so that gives you more flexibility. You can use that syngas then to move forward to transport fuels, for instance, if it's not just electricity. Syngas, the production of syngas versus just heat, also gives you more efficient ways of producing electricity because the syngas can actually run the generator as opposed to just creating or being combusted for heat. And the non-organic materials with gasification do become ash. So you still have about 30% of what you started with as ash, and that has to be tipped again. Or again, as I said, somebody will say we can do this, that the incinerator and pyrolysis or gasification people, can explain what their solutions are for that. Pyrolysis, it's a thermal degradation of the organic materials, and it's an external heat source, so you always have to be powering it, so it's not as efficient as some of the others. Again, the feedstock has to be fairly consistent. You see temperatures of 300 to 800 degrees Celsius. They maintain that for several seconds, and the downfall that we've seen with pyrolysis has been that of the batch process only. Now, I'm hearing that there are those people who are starting to look at running pyrolysis units in a non-batch mode. Now, you may ask what's wrong with batch versus running it continuously. Depends on your output. If you're looking at creating power, you can't just turn it on and off. You've got to start, if it's base load power, you need to run this thing 24/7. And there's a lot of issues with turning these things on and off. You don't just turn it on, get rid of some waste, turn it off, go home, come back and just turn it on. There's warming up periods, there's cooling down periods, etc. So it's batch, but it's not an on-off process. It takes time to do things. You get a char, an oil, and you get a syngas. So again, the syngas does allow you to do some other things. It's not just electricity. If you're looking at fuels, etc., you can go down that route. 2 minutes. Geez, I can't believe all the people here. My mom was going to come over from Canada so somebody would be in the audience. But it snowed. Plasma gasification. Electricity passes through graphite and carbon electrodes. Plasma is supposed to be the fourth element of matter. And temperatures are over 3,000 degrees. Down the vessel, probably 1,600. But you get rid of that issue about furans and dioxins because the temperature is so high. All the organic materials are converted to a syngas. That syngas, again, is good enough to actually run a recip engine, or you can use it for combined, higher efficiency electricity generation, or you can do your transport fuels. The inorganic materials are converted to a inert vitrified slag. It's a glass-like substance that can be used for road base, etc. It's inert, so you're not, you don't have to worry about that coming back to bite you on the butt, so to speak. And it can take any feedstock. You don't have to have refuse-derived fuel, etc. You can just put straight MSW, etc. Sources of revenues, just something to think about. Your tip fees, your electricity. I say electricity, it's any PPA, whether it's ethanol or whatever. The heat, maybe in Canada we think about heating, not so much here. Environmental attributes, you know, the EPAs, etc. There's some funding to be gained there. There's also the levy that you don't have to worry about once you start not tipping things. The aggregate can be used for road fillers, etc. Now I'm under pressure. And you've got, in MSW, this usually 15 to 25 kilograms of metal per ton of waste, so you can recycle that. The water that's recovered is potable water, so that's recycling also. So I just did a synopsis of the different, and I figured you guys would be getting your hands on this, so it's just to have a look at the different technologies and determine the feedstocks that work well with them and diversion from landfill, some of the byproducts. Now, I'm going to shamelessly say that if you're interested, or if you're starting to go down the path for waste to energy, there is a waste to energy conference. The next one's in February. It's in Ballarat, 2.5 days, and it's basically starting from, we think we need a waste to energy project, and there'll be EPA, there'll be financing people, there'll be lawyers, there'll be all the technology vendors to explain what they do will be there. And the idea is a single stream, and at the end of it, you'll go in there and learn a little bit about all the aspects of how to put a project together. So I hope I didn't bore you too silly. Thank you.